Good morning, everybody. Glad the microphone's working this morning. Welcome to this High Performance Architecture Research Group Forum. Convening a number of presentations today around our esteemed guest, Professor Edward Ng. Before I go on, I'd like to acknowledge that we are on Bedigal land today. I'd like to take my time to acknowledge the traditional custodians of these lands, pay my respects to elders both past and present. As we talk about sustainability, the environment, cities, sustainable cities, it's worth acknowledging that the traditional custodians have been looking after the lands beneath the asphalt that we stand on today for tens of thousands of years. So I would like to give a brief introduction to our esteemed guest, Professor Ng. Edward Ng is Professor of Architecture in the School of Architecture at the Chinese University of Hong Kong. He's an architect, specialises in green building, environment, sustainable design. As an environmental consultant to the government of Hong Kong Special Administrative Region, Professor Ng has developed the performance-based daylight design practice note, the air ventilation assessment technical guidelines, and the urban climatic maps and city planning. Professor Ng has published over 500 papers and 3 books. He's twice received the international award from the from the Royal Institute of British Architects. And recently, his village rebuilding demonstration project in Yunnan in China won World Building of the Year award at the 2017 World Architecture Festival. Without further ado, I'd like to pass over to Professor Ng.
My wife came with me, and I hope she's not back down there. If she's an innocent lady, she's smiling, and she's trying to make sure that I say the right thing. Important. Thank you for asking me to come to give a very short introduction to our work. Now, before I start, I think those of you who know Hong Kong or has been to Hong Kong know that we have a tropical kind of climate. And I always talk to the ministers and people like that. For those kind of climate, there are only a few things that you can do to help people living a better life, apart from politics, of course. One of them is, of course, greening, and the other one is the green environment. So in the last 20 or 30 years or so, we have been working a lot on these 2 matters for the building environment in the high density city kind of setting. So I would like to introduce 3 or 4 projects that we are currently doing. So to give you an idea of what we are focusing on. The first one is to help the planners to develop an index. Index means that the planner can very easily use in their work without going into all the scientific details to assess the scheme that has been submitted for their approval. So if the index can be developed in such a way that it is performance-based, then the environment, the subsequent environment could be better. So this is an attempt to see how we can develop an index for our environment, all the way from measurement, from scientifically, all the way to how to do it properly. And we have referenced a few kind of index-based parameters from around the world. One is Melbourne, and one is from Singapore, and see how we can do it slightly better. Now, as you probably can see, the entire scientific kind of process needs to be walked all the way from field measurement to data, and all the way to understanding it to develop this index. Some of this work has been published. Please cite them, because citation nowadays, as you know, is quite important for professors to get their next pay rise. So please cite them. Yeah, I try, and I also encourage your students to cite and their mother to cite it. The other thing is that we work with the modeling team in Germany. Carl Bruce, the team, his team actually at the moment has a slightly better microclimatic model called ENVIMAC. You probably know that already. But we found that actually the model has a bit of problem. And so we work with them to see whether or not we can develop a better guidance as to how to use it better. So next time you try to use this particular software, refer to the paper that I'm showing you to see how it can be configured better in order to give you more accurate result. So this is the attempt to improve the tools that we're going to use for any subsequent studies. So the paper is over there. And after that paper, actually, we work with them again to develop the model library, i.e. not only that you know how to set up the program properly, you only know how to input the data, especially the tree kind of data more properly into the software so that it gives you better results. So next time, if you use this and you try to save your own time, putting in the tree model, then we have some library to actually help you. Hi, the more important people has come, so I have to speak very carefully now. And so this particular work jointly with the modeler is an attempt to try to develop better tools for students. Sometimes they put in the wrong data and get the wrong result. But this is another paper. And then we try to therefore use a better tool to develop the strategies for the government or for the planners as to how to do it better. There is no surprise. I mean, the more the better. But what kind of trees? How do you disposition them? How do you put them together or not put them together? Where do you put it, and what benefit it may result? And we try to understand this outdoor environment at the moment using a transient thermal comfort model, i.e. people moving around, kind of a comfort model, instead of a static one that typically people use for outdoor environment, which is not very appropriate for the highly inhomogeneous, high density environment. Okay, the next one, so this is the green side. So we have been working on that. The next one is the wind side. Wind is a lot more complicated than green because of its, I'm quite sure the professor here on fluid dynamics will correct me. Yes, it's easy, okay? Turbulence is easy to understand, but not according to some professors. I talked to Julian Hunt, you probably know him. He told me that actually, if you ask God a number of questions like quantum physics and things like that, he probably will give you an answer. But when it comes to turbulence, he may not even give you an answer because he's in the devil's kind of realm of understanding. So this is something that we like to understand more. The wind environment for Hong Kong is extremely complicated. So there is no one arrow that can, or one wind rose that can represent it. So we have, when you try to design in such an extremely complicated situation, you have to understand it better. And this is one of the experiments that we are doing together with our meteorologist to use LiDAR. You probably know what is LiDAR, yeah? LiDAR is something that you shoot to the sky and somehow it gives you a signal back to tell you what the atmosphere look like all the way from here to heaven. So then we use this particular LiDAR system to set up a network in Hong Kong to understand the wind profile and the wind characteristics in different time, in different kind of episode, and therefore to make sure that we have that data to put into our mesoscale model in order to later on get a better understanding of the ground level wind environment. So the process is very simple. That one's the LiDAR, one of them, and you just shoot laser into the sky. When we installed this particular device, we had a lot of problem with the police because you know that a few years ago, the students tried to use some laser to shoot at the policemen, but they are the handheld one, and we have the one like that. So, so the police look at it and say, "What is this?" I say, "Laser," and immediately it was not allowed to be put in the city. We say we only shoot shoot God. We don't shoot you. And say, what happens if you put if people put it horizontally? If they put it horizontally, it will shut down. No, we don't believe you. Okay, so we had a hard time trying to install it in the city during the political time, even today. But now we work with the meteorologist. So the observatory people say it's okay, it's okay. You only get blind. It won't kill you. It won't kill you. So using the data from the LiDAR, we therefore fit it into the UOF modeling, because UOF nowadays is very good for those of you who use UOF. UOF is actually a mesoscale modeling system to allow you to downscale the GCM model, the general circulation model, to something that is closer to the city scale understanding. So we try to use UOF to simulate the entire wind environment of Hong Kong. And then we then use Palm. Palm is another LES-based, for those of you who use CFD, LES-based modeling system to basically to downscale all the way to 1 meter resolution. And then at the end, we can do the AVA, i.e. the air ventilation assessment that I have been working with government in the last 20 years. So this is the network of LiDAR that we are setting up. At the moment, we have 4. So we're going to do, and since we have done it, actually the government is very, very good, because they find the data very useful, especially for pollution prediction. So they bought 20. So we will retire those 4 in no time at all. But these 4 are situated in such a way that some of them are upwind and some of them are downwind. It depends on where the wind comes from, and also some in the city area to capture the wind profile and the turbulence characteristics of our city. And using that, we actually find out that traditional way, the wind tunnel way of understanding the wind environment is not suitable for our city. And therefore, using that technology and extrapolate it to city ventilation understanding would be wrong. And so we try to now recalibrate the wind data that planners are using in order therefore that they can assess the urban wind much more accurately. Okay, and then once we come down to the ground, traditionally we all know canyon-based understanding of the wind turbulence and things like that. So as if all the cities make up of a parallel canyon, that the wind will go in and out and things like that. There's a lot of study on that, because a lot of cities are grid-based, but Hong Kong is not grid-based. Hong Kong is very complicated in terms of the street geometry. So we try to say that, okay, if the traditional canyon understanding of the wind environment cannot give us the solution, what can we do? So this is the kind of street layout that we commonly come across in Hong Kong. And if in those situations, what can the planner do? Canyon understanding will not apply. So we therefore set up this particular program to understand the kind of what we call the odd kind of geometry of the street and width, and together with the open space, how are we going to characterize them to come up with some kind of simple understanding that in those situations, planner can have a way to guide the city planning. So all the way, including the use of wind tunnel and CFD. These are some of the models that we built for different kind of street configurations, and none of them is canyon-based. So how are we going to understand those? So we do a kind of massive parametric studies, including all the factors that we think might be of interest, to see how we can come up with some kind of ideas. So these are some of the ongoing studies. Some of them are published, so it's still ongoing. So so for those of you who want to understand kind of odd geometry, wind environment in high density cities, then these are some of the publications that could be of interest. Now, this is the last project that I would like to introduce. This project is very big. It's funded by our research council, 8 years project, 10 professors. So it's a multidisciplinary project that we try to put 3 things together. One is, of course, the climate meteorological side of it. The other one is the built environment. But more importantly, very importantly, it's the service. These are the doctors, nurses, psychologists, and also social workers. They have to find ways to help people on the ground live a better environment in the future. So in the middle, of course, is the health impact to elderly. So this particular studies focus on elderly, i.e. me, okay? So people like me and beyond. So how they could live a better life in the near future. In the near future means 2030 and onwards. So if you are 60 and above in 2030, okay, so we would like you to be one of our samples. Come to Hong Kong and we'll interview you and make sure that I will torture you and see how you can survive in our environment before we allow you to back to Australia. So, but the more important thing about the program is that not only the universities, 4 universities join hands, and but we also gang together the observatory people, the Green Building Council, and also the planning department, and also the public health service department, because they are the people who eventually need to formulate strategies and also policies to enable some of the things to come together. Now, this is our modeling people. Now, as you can see from the GCR model all the way to the hourly data, we use we downscale it using our particular method of urban parameterization, which allows us to very accurately predict how the ground environments look like, and conclude with the hourly data from now to 2100 all the way. So we know the episodes, now and the future, and with that episodes, we therefore calibrate the kind of health impact with our doctors. So we know that if you have an episode that looks like this, hot night and hot day in a certain kind of combination, then the death rate will go up. And then we use this particular data set to tell the observatory people, don't tell me that tomorrow there will be a hot day, because it won't happen. It won't matter. Tell us that in 3 days' time, there will be an episode that looks like this coming. So the health service people therefore have 3 days in advance to prepare themselves to visit the older people, to make sure that the whole thing is prepared for the episode to come. So in the past, they only tell you what's going to happen tomorrow, but now they tell you what's going to happen in 1 week's time. So you have time to prepare. So this is the change that we have made to the meteorological people, because if we tell them that if an episode like that coming, you better tell people to do something. And they have already kind of stepped into their daily routine. So every day nowadays, you look at the observatory website, they'll tell you that in 3 days' time, you're going to suffer. Okay, something like that. Okay, or do something, otherwise you will suffer. So this is one. The other one is to inform the regulators that if you continue, this is actually the work done by Gao, your student. Yeah, but the students who finished his PhD here, I think Max student. Yeah, he's not a very good student. Yeah, not very good one. Okay, but anyway, one of Max's students, he actually helped us to do this, basically to tell the regulator that if you continue to design or regulate building for the future like this, most of the buildings cannot provide a suitable environment. That was the message to them. Now they're changing the building regulation for the future, because now we have the data all the way to 2100. Therefore, we know what is going to happen in the future. And we now need to change the regulation now for the building that they're going to build tomorrow, all the way to 2100. Indoor and outdoor. Outdoor spaces, we also tell planners that we need some other facilities. And more important is to tell the old elderly and also the service supporter that something needs to be done. For example, we find out actually together with the doctors that if the old lady in a home report that she's hot or she's feeling hot, it's already too late. She's dying already. Okay, it's time for you to send her to the hospital. So it's too late when she tells you that she's not well, because of the physiology of the old lady. So what we are doing now is to preempt that. This is the reason why the observatory warning is extremely important, because when that warning comes, the whole support system, the health service are activated. They need to do something. They need to call the person and say, are you dying yet? And things like that, okay? Or drink some water before you die, okay? Thank you. You have to preempt the problem. So we have actually help all the NGOs to have this kind of preparation mechanism. Once that happens, we find out that actually the problem has decreased quite dramatically, because preparation is always better than cure. So this is the one thing that we work with the doctors, nurses, and social workers to help to PM the situation and to solve the problem before it happens. And I won't want to go into that because I'm running out of time. So this is Gao's work. It's very complicated. So I don't want to talk about it because it's beyond me. But he seems to enjoy it very much. And the more important thing is that we come up with this tick box. I tell my mom, say, go home, tick all the boxes and see whether or not you find some of these features. So she tick the boxes, and then I show the boxes to the estate developers. They say, my mom doesn't like your flat. Sorry. So a very simple way for the elderly to know what kind of environment they are in, and therefore that information is fed back to people who are providing those environments. So some of these are architectural, so I don't want to talk about. These are all Yiling's work. Yiling's is one of your students as well. So it seems that all the more important people that we are using to help solve our problem come from you. Okay, so either you have good students, or unlikely you have good teachers. I don't know which one. Okay, you decide. Okay, I don't care. But please continue to send your students to us. We will use them very well. Okay, use them nicely, very well. So she's very good. She helped us to do all these diagrams to tell my mom how not to open the window and things like that. This is important. This is the one that we actually gave the government a really hard time. So we actually combine the Herbert Island understanding, the wind environment understanding, another socio-economic understanding. We know where the poor people stay. And we map the problematic area, which are the red area, together with the social service support area. We find that they don't match. So we have a heat shelter in the richest part of Hong Kong, that people, when they feel the heat, they are in Switzerland already. And on the other hand, some of the poor area has only one. So we told them that actually you're not using your resources properly. So the government now is taking notice of that, and in those red area provide a few more in a certain way. So we activate the actors and our celebrity to tell the government the same story. He's not an actor, he is a celebrity. Everything that he says, and people listen, trust. So we ask him to say for us that the government is not doing a good job, something like that. So if the government want to kill somebody, they kill him, they don't kill me. So it's okay. Okay, so now we are in halfway of the program, and we are going to finish it in 4 years' time, hopefully a year-round understanding. So this is just 2 more slides. Can you go to that website? For those of you who want to visit our website for this particular program, you can visit this. You can take picture now together with me, of course. So if you Google, you'll probably be able to find it. Extreme hot weather, elderly, Hong Kong, and some of the publication and things like that are all featured here. As I told you, the team is extremely large. So now, the one thing about the large study team is that architects are okay, engineers are all right. Wait until you work with the doctors. Doctors are very difficult to work with because they believe they know everything. They can solve all the problems by themselves. And this particular doctor, he's very famous. She's very, very, very famous. So it's extremely difficult to work with her. But on the other hand, if she's convinced that what you're doing is good for mankind, mankind means mankind, and mankind means humankind, okay, not just man, then she will be very, very happy and she will help you. And she only need to say 2 words. It's much better for you to say giving a long lecture. You only say, if you don't do it, you will die. All the ladies in front of her, old ladies, stood up and protest. Okay, she only need to say that because she's very famous. But it's very difficult to work with her. So next time you work with difficult people, you're not one of them. I'm quite sure. Yes, yeah. make sure that some dividends will come if you have patience. Okay, you have to really work with them nicely, and then it will pay dividends. Difficult people are normally, I mean, like Matt, I mean, he's difficult. So yeah, you see a lot of people. But he's very good. So if you can win his heart or her heart, then you solve most of the problem already. So that's my message to you. Work with difficult people on difficult problem, and you probably will survive better. Now, once the website. Now, one website I would like to highlight to you. Actually, I highlighted to people in Melbourne when I was there. That website. Yeah. No, the PowerPoint. Yeah, with the website. Okay. So now, this is important to know. Recently, this document came out. For those of you who are interested in urban heat island studies, you must make reference to this document. This document is important in that it lays out the groundwork of the scientific understanding of what urban heat island studies should be about. Number one. The second more important thing is in the past, if you talk to anybody from WMO on urban heat island, they will ignore you because you are polluting their data set, you are polluting their understanding. But since the WCC3 many years ago, they changed their mind. And increasingly, they are publishing this kind of official document worldwide to guide the meteorological services to help you with your urban heat island studies. So if you study it, next time you talk to the meteorological people, they cannot ignore you. They will help you. And from this point onward, actually, the study of urban environment is official in the climatological circle. And you go to UN, you go to UPCC or UFPCC, they cannot ignore you. So the last 50 years, the community, including Matt, has championed that this kind of study to understand the urban environment is important. They have so far ignored us. But only in the last few years, they start to publish guidelines to do things properly. And this is one of the few guidelines that they have already published, and they're going to publish to shape the future of policy. Since it is a UN document approved by the General Assembly, nobody can say no. Nobody can tell you that you are an idiot anymore. No more. Okay. I'm quite sure, Matt, nobody call you idiot, but they sometimes call me idiot. Anyway, so I recommend you to refer to this particular document a little bit more next time you do urban climate studies. Thank you.